All right, let's go ahead and start reviewing for the final. I'm going to work through a couple problems from the final exam review. And I'm not going to do them all. Be sure you carefully review and compare your answers with those on the answer key, and the ones you don't understand, go and investigate more. Ask me about them if you need to. I'm going to just highlight some that I wanted to look at. So let's look at problem number 6. All right, on problem number 6, you have a right triangle. You're given the 70 degrees, and you're given that this over here is 10 units, and they've got it labeled like so. All right, and your job is just to find the length of the unknown side. And so what you need to do is focus on the given information and the relationship that you could use. Which trig relationship would it make sense to use? So since 10 is the leg that is adjacent to the 70 and C is the hypotenuse, that tells me I'm going to set it up using cosine. So I know the cosine of 70 degrees would equal 10 over C. All right, and so then from there, you need to show the solving of that. So I'm going to multiply both sides by C. So when I do that, when I multiply both sides by C, let me show it. The C cancels. I get C cosine 70 equals 10, and I'm trying to get C. So once I'm here, I'm just going to divide both sides by the cosine of 70. Okay. And then I just need to work that out. And 70 is not a special angle, and the directions say round to 2 decimal places if necessary. So that means you're going to go to your calculator. Remember to check your, I'm going to write it, your mode. So for this problem, I need to be in degrees, don't I? So make sure you're in degree mode, especially if you haven't just been working problems. And then you're just going to do 10 divided by the cosine of 70. All right, and when I do, I wind up with C being a decimal. I'm going to use approximately here, and they said 2 decimal places, so that would be 29.24. And that's all they want on that one. Okay. All right, I also wanted to look at question number 7, because what it does is it says that this point, 3, -2, is on the terminal side of an angle, and they want you to find the exact value of the indicated trig function. So you wind up having this point, 3, -2, that's on the terminal side of an angle. So here's your terminal side, here's the angle they'd be talking about. And then your job is to find sine theta and cotangent theta. All right, so a good way to do that, like we've done a million times, is to draw your right triangle. Make sure you're drawing the perpendicular going to the x-axis. Then this is 3 and this is -2. This is the point that has the coordinates 3, -2. And you can use the general definitions to get this, but you also can kind of look at it and think about it in terms of the picture. So whichever you're more comfortable with. So this one wanted the sine of theta. And so it's not just -2, because this point is not on a unit circle. So it's not just the y coordinate of the point. It would be the y coordinate over r is the way it was defined. So we need to get r, don't we? This right here. And we can do that by using the Pythagorean Theorem. So we know r squared would equal 2 squared plus -2 squared plus 3 squared. So that's 13. And so r would be the square root of 13 here. And so that means my sine would be the y coordinate over the r, and I need to rationalize that. And so I multiply top and bottom by square root of 13. So that would be sine theta. And then cotangent would be cotangent of theta. Tangent would be opposite over adjacent, so this would be adjacent over opposite. You could do it in terms of your coordinates too, can't you? So it'd be 3 over -2. Okay. All right, the next one I wanted to do is the one I'm most worried about and that you need for other things, where you're dealing with reference angles. You're not going to get any credit for these if you just type this into your calculator and give me a value. Okay, you need to show me that you were thinking about the reference angle. And it says to use reference angles and special triangles to find the exact value of the expression. And I'm asking you on these not to use the calculator or the unit circle. So if you're trying to find the tangent of 7 pi over 6, what you got to do is think about where that's located. So think about the pi being cut into sixths. Okay. All right. So that would be 1, 2, 3, 4, 5, 6 pi over 6, right? This is 6 pi over 6. That's pi. And then I'd be at 7 pi over 6. So I'm right here. Now, technically, you do have a unit circle. So you should be able to double check your work by looking at it. But the idea is this, that if I want to find a trig function of that angle, I can focus on just this piece right here and think about a right triangle right there and trying to figure out what it is by looking at just that right triangle. Okay. And see, when I do that, I'm blowing this up out here. So this angle right here, since I'm pi over 6, this is pi over 6 past that. This right here is pi over 6, which is just 30 degrees. Okay. And so I know if this is 30 and this is 60, that I have a special right triangle that's 1, 2, oops, got it off. Okay, the 2 goes on the hypotenuse. The triangle's just kind of upside down. So 2 would be the hypotenuse and square root of 3 would be opposite the 60. And so now I can look at that and I can see this 30 degrees, that's your reference angle. And so I can see that, okay, so my tangent is going to be opposite over adjacent, which is 1 over the square root of 3. So be careful though. But you got to think about the quadrant you're in, right? So when you're in that quadrant, your tangent really would be positive. So the tangent of 30 degrees, which is over here, we're using that. So we have to sometimes adjust and make it a negative. But in this case, the tangent in that quadrant is going to wind up being positive. So that would be it, except for it would need to be rationalized. And so your final answer would be square root of 3 over 3. Okay. All right. Now let's look at number 10. This one's in degrees. It's dealing with secant. And if I thought about 585, I would go around one whole time would be 360. And then let's see what I would have left after that. I'd have 225 more degrees to go. So that means I'd go 180 and then another 45. I'd be right here. So that would be 360 and then another 225 would get me to 585. All right, well, I know I'm trying to do the secant of 585, but the reference angle would be this one, would be the angle formed by the terminal side and the x-axis. And so see how that would be past 180, just 45 degrees. So that means this one could be done by thinking about a 45, 90 degree triangle because the reference angle is 45 degrees. And that has the ratio 1 square root of 2. Okay. And then I have to think about secant. Only what I usually do is secant is related to cosine, isn't it? So I usually just do the cosine of 585. Well, the cosine of 585, I'm going to do by looking at the cosine of 45 first. And I know that's equal to positive square root of 2 over 2. Okay. But then I'm going to think about how I'm over here in the third quadrant, and I can see how cosine is negative over there. So the cosine of 585 is actually going to equal a negative. You have to put that on it, square root of 2 over 2. Okay. All right, now that's not my answer because it asked me for secant. So now what I'm going to do is say, all right, well, secant, then of 585 should be the reciprocal of that. Only now, because of the fact I rationalized the square root of 2 over 2, I'm now having to rationalize again. And I'd wind up with negative square root of 2 for the secant. All right, now what I could have done is right here just left it as 1 over the square root of 2. So when I flipped it, it would turn out to be nice. Okay, the part of this that the reason I'm doing it, the part of this that I think people aren't really getting is that even though we're trying to find the cosine of 585, we boil it down to the reference angles, which are those angles between the x-axis and the terminal side. And then the numerical part of the cosine of 585, the numerical part is equal to the cosine of that reference angle. And then you consider the quadrant you're in to determine whether that's positive or negative. And since cosine is related to the x-coordinate, when I'm over to the left here, okay, cosine would be negative. So that's why I threw the negative on there. All right, and I wanted to do one more that's in the that same section. I think that's it. Yeah, one more that might be good to look at that came from that early part was number 14. It's been a while since we've done that, and there's something about the way that's stated. I think I gave you one like this on the final, but I stated it slightly different. I don't want it to mess you up. This says you've got a wheel, and it says it has a 17-inch diameter. That means all the way across is 17 inches. And it's turning at the rate of 34 revolutions per minute. And you want to find what the speed is for a point on the rim in inches per minute. So you want to know, how fast is this going around here? All right, so what we did before is we would take the radius, okay, and we would multiply it by the revolutions per minute. And then we would multiply that by the radians in 1 revolution. And then that would cause you to have everything turn out to have the units what you need them to be. The issue here is don't get tricked by this. 17 is the diameter. So if they give you the diameter, you would have to cut that in half. Then 8.5 is the radius. I think on the test I made it a radius. So this would be 8.5. That's 0.5. Then I'm going to multiply by 34 revolutions per minute. Then I'm going to multiply by 2 pi radians in 1 revolution. And then I just work that out. So take the 8.5 times the 34 times the 2. And that tells me the answer is going to be 578 pi if they want it in terms of pi, and then just multiply by pi to get an approximation for that. This one said round to the nearest inch, so it would be 1,816 inches per minute. Okay, now more interesting would be if they said miles per hour, so you could get a sense of how fast the car would go. All right, so that is the material I thought it would be worth going over from 5.1 to 5.7.